Hello student, welcome back to lecture series on linear differential equation with a constant coefficient. We have started lecture series for a symmetrical simultaneous differential equation. Within that I already explained method of grouping or combination of a method of combination, okay, that I already explained with the example. In my last lecture I explained to you all how to use method of multipliers with some of the example also, okay. So in my today's video I'm gonna explain to you all this example, okay, using method of a multipliers. Okay, this one is our symmetrical simultaneous differential equation. Okay, I'm going to solve this method using method of a multipliers. Okay, yes. Now when we apply method of a multipliers, always remember that we want the denominator 0. Whenever denominator goes to 0, then these are the variable that gives us our required answer. Okay, so let's consider first of all three variables. So these are the equation. Symmetrical simultaneous differential equation is in the form of, what is the form? Dx by p, which is equal to dy by q, okay, and which is equal to dz by r. Okay, this is our standard form here. Okay, so p which is equal to u, p which is equal to this thing, q which is equal to this one, and r which is equal to this one. Okay, yes. Now we want the variable that we can multiply to this term, multiply to this term, multiply to this term, and we write their addition is a 0. Okay, so you have to consider L, first L, second M, and third N. Okay, so we can see that if we add x, y, z as L, M, and N, okay, if we multiply x, y, z to the all denominator, it obviously gives us the value 0. Now see that if you're going to multiply x to the denominator, see that 3xz minus 4xz. Okay, so you can cancel with the remaining terms here. Okay, if you multiply z to the here, okay, or y to the here. Now let's multiply and let's verify, okay, how it is look like. Okay, I'm going to write dx by 3z minus 4y, which is equal to dy by 4x minus 2z and dz by 2y minus 3x. Okay, I'm going to write this one as, okay, multiply L dx plus m dy plus n dz. Okay, L dx plus L dx means x dx, x dx plus y dy plus z dz. Okay, x dx plus y dy plus z dz. I multiplied and add their numerator as we have given in our required method. Okay, similarly multiply x to the denominator and add up all of them. X into 3z minus 4y plus y into 4x minus 2z plus z into 2y minus 3x. Okay, so this one is the complete steps here. Okay, yes, here dx plus dy plus dz. I multiplied x and added to the numerator x, y, z and added numerator. Similarly multiplied x, y, z and added denominator. Okay, so if you are going to calculate that denominator, okay, x into 3z minus 4y plus y into 4x minus 2z plus z into 2y minus 3x. Okay, if you are going to add entire term, obviously you will get the value 0. Okay, so if you are going to add this entire term, you will get the value 0. So if denominator gives us the value 0, then we write x dx plus y dy plus z dz. It gives us the value 0. Okay, so if it gives us the value 0, then apply integration to the all terms. X dx plus integration of y dy plus integration of z dz. Okay, which is equal to 0. Integration of x, which is a x square by 2, integration of y square by 2, integration of z square by 2, which is equal to c1. Okay, as a first constant. Take 2 to the other side, we write x square plus y square plus z square, which is equal to 2 times c1, and it behave only the c1. Okay, so we got the x square plus y square plus z square, which is equal to c1. Okay, is the our required first solution. Okay, let's work for the next another solution. Okay, in another solution we want some another values. Okay, for L, M and N, that gives us L dash, M dash, N dash, that gives us the value for given function. It is addition for denominator is a 0. Okay, for the second function, okay, you have to find out, you have to figure it out which are the possible value that can our function gives us the value 0. Okay, so if we multiply 2 to the this part denominator, 3 to the this denominator, and 4 to the this denominator, okay, this entire term gives us the value 0. Okay, so what I consider L dash is a 2, M dash is a 3, and N dash is equal to 4. Okay, are 3 different multipliers. Okay, so I'm going to write this one with our given equation. Okay, so what is our given symmetrical simultaneous differential equation? Dx upon 3z minus 4y, 3z minus 4y, dy upon, okay, I'm going to write dy upon 4x minus 2z, 4x minus 2z, and dz upon 2y minus 3x, 2y minus 3x. Okay, I written symmetrical simultaneous differential equation as it is over here. Okay, yes. So what we do, we are going to apply L dash, M dash, N dash here. Okay, that means 2 dx plus 3 dy plus 4 dz. Okay, so how it is look like? 2 dx plus 3 times dy plus 4 times dz. Okay, I'm going to write 2 dx plus 3 dy plus 4 times dz. To again do it similar to the denominator, 2 into 3z minus 4y. Okay, 2 into 3z minus 4y plus 3 into 4x minus 2z, 3 into 4x minus 2z. Okay, 3 into 4x minus 2z plus 4 into 2y minus 3x plus 4 into 2y minus 3x. Okay, this one is the denominator. Okay, so if you're going to add their denominators, obviously you will get the value 0. That means 2 times okay, 3z, 2 times 3z, this one is a term z, minus 4y. Okay, I'm writing this denominator, plus 3 times 4x minus 2z plus 4 times 2y minus 3x. Okay, this entire term gives us the value 0. If you're going to add, obviously this term goes to 0. So if this term goes to 0, then we write 2 times dx plus 3 times dy plus 4 times dz. Obviously this one also goes to 0. Okay, so if denominator gives 0, then we write numerator 0. This one is our standard method. Okay, yes. So it is easier to remove dx dy z, apply integration, 2 times integration of dx plus 3 times integration of dy plus 4 times integration of dz, which is equal to 0. Now see that as we have dx, dy, dz. Okay, so I take a constant out from here. Okay, integration of a dx is a x, so 2x plus the integration of a dy is a y, 3y, plus integration of dz is a z, so 4z, which is equal to c2. Okay, 2x plus 3y plus 4z, which is equal to c2. So this one is our f of x, y, z, which is equal to c2. Okay, this one is the second function, this one is the first function. Okay, so c1 is equal to x square plus y square plus z square. This one is the first solution for our symmetrical simultaneous differential equation, and 2x plus 3y plus 4z, which is equal to c2. This one is the second solution for our symmetrical simultaneous differential equation. Okay, I hope you all have understood, guys, my entire solution. Okay, that is here for the solution. Even after, if you found anything difficult, guys, let me know in my comment section. I will come up with the similar videos. Okay, and if you want to see more similar videos, let me know in my comment section. Okay, and if you want more any difficult or anything confusing is there in your syllabus, let me know. Give me the point in my comment section. I will come up with the similar videos. Okay, so thank you everyone. Thank you for my today's lecture.